Alright everybody, welcome back. This is going to be the third and final video for section 9 of unit 2 of AP Calculus, the quotient rule. And what we're going to do in this video is we're just going to look, we have one last example we're going to look at. In this example we've got two functions u and v, and we're defining them numerically where we know the values of the function at a single point and also the values of their derivatives at a single point. And we're using them to find the values of various derivatives involving those two functions at that single point. So you see here that we've got the definition of all of our values. U of negative 2 is 3, v of negative 2 is negative 4, u prime of negative 2 is 2, and v prime of negative 2 is negative 5. And so we're going to go ahead and we're going to find the values of all of these derivatives at x equals negative 2. So the first thing we're going to do here is take the derivative of u times v. And so remember that the derivative of u times v is going to be u of x times v prime of x plus v of x times u prime of x. And so if we want to find the value of this derivative at x equals negative 2, all we need to do is we need to take u of negative 2 times v prime of negative 2 plus v of negative 2 times u prime of negative 2, and then we can just go ahead and find the values for all of those from our list above. U of negative 2 is 3, v prime of negative 2 is negative 5, v of negative 2 is negative 4, and u prime of negative 2 is 2. And so we go ahead and calculate those out, and bada boom bada bing, we find that the value of the derivative of u times v is negative 23. Okay, let's go ahead. We'll move on to part B, the derivative of u over v. And in this case, we're going to use the quotient rule to take the derivative of this. So we've got low times the derivative of high minus high times the derivative of low, square the bottom, and away you go. And so that's what we're going to use as our general template to find the values of the derivative of u over v. And so since we're doing that at negative 2, we want to substitute negative 2 into all of these. And so we've got v of negative 2 times u prime of negative 2 minus u of negative 2 times v prime of negative 2 all over v of negative 2, quantity squared. And now we're just going to substitute in the numerical values that we've got. And so we've got v of negative 2, which is negative 4, times u prime of negative 2, which is 2, minus u of negative 2, which is 3, times v prime of negative 2, which is negative 5, all over v of negative 2, which is negative 4, the quantity squared. And that equals, let's see, negative 8 plus 15 all over 16. So 7 over 16 is going to be the value of the derivative of u over v at x equals negative 2. All right, we got a part C and a part D here. It's going to be a little weird. You might, you might have to scroll back and forth here to get values, but we're first taking the derivative of v over u. This is going to be very similar. Again, we're going to use the quotient rule. So we've got low times the derivative of high minus high times the derivative of low, square the bottom, and away you go. And so we're going to now want to substitute all those values in here. So we'll go ahead and do that. U of negative 2 is 3, and v prime of negative 2 is negative 5, and v of negative 2 is negative 4, and u prime of negative 2 is 2, all over u of negative 2, quantity squared. And so we go ahead and calculate this. That gives us negative 15 plus 8 over 9, And we end up with -7/9 as the value of our derivative here. And then we've got one last problem to do here. I'm going to scroll back up so that I can see the values of the functions. And so we take the derivative of 5u minus 3v plus 4uv. That's going to be 5u prime of x minus 3v prime of x plus 4 times the derivative of uv. And I'm going to do that because I'm cheating on this problem. I'm cheating on this problem. So you'll see what I mean when I get there, how I'm going to cheat in this problem. So we've got 5u prime of -2 minus 3v prime of -2 plus 4, and the derivative of u times v was what we found up here in part A, the derivative of u times v at -2. So I'm just going to go ahead and I'm going to cheat and not redo, not reinvent the wheel. I'm going to go ahead and use that value that I already found in an earlier problem. And now I can go ahead and substitute the values in. So I've got u prime of -2 is 2, and v prime of -2 is -5. And now I can go ahead and do all my calculation, and I've got 10 plus 15 minus 92, and that all gives me -67 for the value of the derivative of 5u minus 3v plus 4uv at x equals -2. Okay, that's it for our videos related to the quotient rule in section 9 of Unit 2. Come back and join us next time when we get into section 10 of Unit 2, which are the derivatives of the rest of the trig functions other than sine and cosine. Since we already know the derivatives of sine and cosine, we're going to develop the derivatives for the other 4 trig rules in our next section. See you then. Have a great rest of your day, everybody.